Welcome. Today we will determine the domain and range of 4 functions. We will sketch the graph of each function to visualize its domain and range. The 4 functions are f of x equals the square root of x divided by x minus 4. F of x equals 1 over the square root of x squared minus 4x. F of x equals x minus 1 divided by x minus 4. And f of x equals the square root of x minus 4. Recall that the domain is the set of all input values, usually x values, for which the function is defined. And the range is the set of all possible output values, usually y values, that the function can present as the input varies over its domain. Let us begin. The yellow curve shows f of x equals the square root of x divided by x minus 4. For a square root to be defined, the expression inside must be greater than or equal to 0. So we need x divided by x minus 4 to be greater than or equal to 0. Also, the denominator x minus 4 cannot equal 0. So x cannot equal 4. We perform a sign analysis of the rational expression x over x minus 4. The critical values are x equals 0 and x equals 4. When x is less than 0, both x and x minus 4 are negative, so their quotient is positive. The expression is defined here. When x is between 0 and 4, x is positive and x minus 4 is negative, so their quotient is negative. The expression is not defined here. When x equals 0, the numerator is 0, so the expression equals 0. This is allowed. When x is greater than 4, both x and x minus 4 are positive, so their quotient is positive. The expression is defined here. Therefore the domain is the closed interval from negative infinity to 0. Union the open interval from 4 to positive infinity. Domain equals the set of x such that x is less than or equal to 0, or x is strictly greater than 4. For f of x equals the square root of x divided by x minus 4. The square root is always non-negative, so f of x is always greater than or equal to 0. At x equals 0, f of 0 equals 0. So y equals 0 is achieved and is in the range. As x approaches 4 from the right, the fraction grows without bound. So f of x grows without bound. As x approaches negative infinity, the fraction approaches 1 from above. So f of x approaches 1 from above. Therefore y equals 1 is never achieved. The range is the closed interval from 0 to 1. Union the open interval from 1 to positive infinity. Range equals the set of y such that y is greater than or equal to 0 and y is not equal to 1. The blue curve shows f of x equals 1 over the square root of x squared minus 4x. For this function to be defined, the expression under the square root must be strictly positive. So we need x squared minus 4x to be strictly greater than 0. We factor x squared minus 4x equals x times x minus 4. This product is strictly positive when both factors are positive, giving x greater than 4, or both are negative, giving x less than 0. At x equals 0 and x equals 4, the product equals 0, making the denominator 0. Not allowed. Therefore the domain is the open interval from negative infinity to 0. Union the open interval from 4 to positive infinity. for f of x equals 1 over the square root of x squared minus 4x. Since we divide 1 by a positive square root, f of x is always strictly positive, as x approaches 0 from the left or x approaches 4 from the right. The denominator approaches 0. So f of x grows without bound, as x approaches negative infinity or positive infinity. F of x approaches 0 but never reaches it. Therefore the range is the open interval from 0 to positive infinity. The red curve shows f of x equals x minus 1 divided by x minus 4. This is a rational function. The only restriction is that the denominator cannot be 0. The denominator x minus 4 equals 0 when x equals 4. Therefore x equals 4 must be excluded. There is a vertical asymptote at x equals 4. The domain is all real numbers except x equals 4. Domain equals the union of the open interval from negative infinity to 4 and the open interval from 4 to positive infinity. For f of x equals x minus 1 divided by x minus 4. As x approaches infinity, f of x approaches 1. So y equals 1 is a horizontal asymptote. Setting x minus 1 over x minus 4 equal to 1 gives a contradiction. So y equals 1 is never achieved. The range is all real numbers except y equals 1. Range equals the union of the open interval from negative infinity to 1 and the open interval from 1 to positive infinity. The orange curve shows f of x equals the square root of x minus 4. For the square root to be defined, x minus 4 must be greater than or equal to 0. Solving, x must be greater than or equal to 4. Therefore the domain is the closed interval from 4 to positive infinity. For f of x equals the square root of x minus 4. The square root is always non-negative. At x equals 4, f equals 0. As x increases, f increases without bound. Therefore the range is the closed interval from 0 to positive infinity. Now let us compare all four functions together on the same graph. Observation 1. Domain. The square root of x over x minus 4 has domain negative infinity to 0 closed. Union 4 open to positive infinity. 1 over the square root of x squared minus 4x has domain negative infinity to 0 open. Union 4 open to positive infinity. X minus 1 over x minus 4 has domain all reals except x equals 4. The square root of x minus 4 has domain 4 to positive infinity. Closed at 4. Observation 2. Range. The square root of x over x minus 4 has range 0 to 1 closed open. Union 1 open to infinity. 1 over the square root of x squared minus 4x has range 0 open to positive infinity. X minus 1 over x minus 4 has range all reals except y equals 1. The square root of x minus 4 has range 0 to positive infinity. Closed at 0. Thanks and best wishes to you.